Hello everyone, welcome back to ATPeak Open Source AR Talk Series. My name is Gaëlle. Today we're super excited to have Adam Harwood from Ultraleap to join us and to talk about the latest development in hand tracking technology. Alex, you want to introduce us to Adam?
Yes, for sure. Yeah. So Adam is the XR engineer at Ultraleap, where he directs R&D efforts to expand the capabilities of both haptics and hand tracking technology. He made his first demos using mid-air haptic and hand tracking tech both in VR and AR, and has been fascinated about ways to prototype and interact with virtual worlds ever since.
Yes, and today Adam will give us an overview of the landscape in OpenXR hand tracking, open source tooling, and where things are headed. So enough about us. Adam, please go ahead.
Thank you. Thank you for the introduction. As Alex and Gail were just saying, I'm the XR engineering lead at Ultraleap. Got a background in Unity development and computer science. And today I'm going to be sharing some information about the kind of open technologies that you can use to use hand tracking in AR. So we'll start with an intro to hand tracking, kind of a bit more information about what it is. And then I'm going to talk about OpenXR and how you can use that to get hand tracking data. Then we'll look a bit more at the kind of tooling ecosystem for the game engines, particularly focusing on Unity and Unreal. And then finish off with a look at the future, so both what we're doing at Ultraleap and also some predictions for hand tracking in general. So what is hand tracking? Well, at its most basic, it's when the computer knows where your hands are and what they're doing. So we can see in this clip, there's a hand on the left, and on the right, there's a kind of virtual representation of it that is reflecting the motion and the position of the hand. And that's kind of really what it's all about. There are a bunch of ways you can do this. You can do it with gloves that sort of track the rotation of each of the joints of your hand. You can use capacitive sensors on controllers. So, for instance, the valve index controller can sense where each of your fingers are to a degree using capacitive sensors built in. And then you can do it with optical technologies, which is how Ultraleap do it. So we use cameras that we put on front of or built into headsets, and then we track the hands using them. So hand tracking is pretty important for augmented reality because it's the kind of main input mechanism. So by this, I mean it's the way that the user tells the computer what they want to do. And you can think of it a bit like the touchscreen is for smartphones. It's kind of the main way that you provide your intent into the device. Hand tracking is particularly good for things like presence and immersion. So it really helps you suspend your disbelief and believe that this virtual object that's in front of you that you're interacting with is actually part of the real world almost. And it's very, very natural for humans to interact with our hands. And so we find that hand tracking is a really great way to get hands-on, as it were, with content in AR. So let's start talking about the tech. So OpenXR is a standard for interoperability between content and hardware, basically. I'm not going to go into that much detail about OpenXR in general, but if you want to know more about it, there was a great talk that Jacob Bornkrantz gave in this talk series a few weeks ago on Monado, and I suggest you watch that if you want to know more information. I'm going to focus on the hand tracking part of OpenXR and start by showing the classic image to explain OpenXR, which is this. So this is the kind of old way of doing things. This is the bad way. So here we can see if you're building an XR application and you want to deploy it to multiple different headsets or runtimes, if each of them has their own proprietary API, then you've got to support every single one of them, which is a massive pain and ends up with this kind of mess. Now you could draw the exact same diagram for hand tracking. You could have, Ultraleap and, well, actually HoloLens 2 and Oculus as well. And the old bad way of doing things is where we all have our own proprietary API, and you have to support all of them if you want to deploy an app to all of those different headsets. So what OpenXR does is introduce this new API in the middle. And what we do is each of the hand tracking providers support this same API. So we provide this single standard API to applications and game engines and so on. So if you build against that, you know that it will run on any of the headsets that support hand tracking. So the hand tracking part of OpenXR is the extension. It's called EXT hand tracking. And the API provides this information. So here we can see we've got a number of points of interest on the hand. We tend to call them joints. And we get the position and orientation of each of these joints, along with some other information such as radius. And you can use this information to kind of reconstruct the hand. It's enough information to be able to drive a rigged hand model, allowing you to do visualization, and to understand what kind of pose the hand is in. So these 26 joints here have been agreed between all of the providers of hand tracking, and we're all kind of supporting this. And you can be sure that if you use the EXT hand tracking API in OpenXR, then you will be able to get these 26 joints. And that's from all tracking providers, not just optical providers. So for instance, you can even use this with valve index controllers. The ecosystem for OpenXR is still maturing. Most parts of it are already in place today. There's just a couple of missing pieces, which I'll touch on later. So the OpenXR API is fairly low level. It's a C-level API. And the chances are that if you're using it, you won't actually be using it directly. You'll probably be using some sort of middleware or something else. So if you actually want to use OpenXR, how do you do that? Well, the first thing you need is a runtime. So there's kind of two main runtimes you can be using if you want to do AR, particularly with a North Star. So on Windows, you can use SteamVR, which is an OpenXR runtime. And there is a community-supported North Star SteamVR driver, which is really cool because you can then just run SteamVR apps on your North Star. And then to get the hand tracking on top of that, you can use the Ultraleap OpenXR API layer. And what an API layer essentially does is bolt on additional functionality to the runtime. So we are kind of just sitting on top of the runtime and providing hand tracking information. So when the application talks to the runtime via the OpenXR API, our API layer just sort of comes in and says, if you want hand tracking data, here it is. If you're on Linux, then you can use Monado, which is an open source OpenXR runtime. And for hand tracking, it supports index controllers and also Leap Motion v2. So once you've got your runtime in place, you still need to be able to actually use that data and write some software. So you've got a few options here. So I mentioned that there's still a few bits that are still maturing, and that's this on this sort of right-hand side here with Unity and WebXR. I'll touch on that in a moment. But today, Unreal Engine already has support for the OpenXR hand tracking API, and I'll show you how to turn that on a little bit later. I've put the C++ logo here, but what I kind of mean is native app development. So if you're writing native code, then you probably want to be using the OpenXR API directly. And there's also StereoKit, which is a C# code first framework for building OpenXR applications. And again, there's a really great talk on this by Nick Smith, who is the maintainer of StereoKit. And this was part of earlier talk series that was on in the year. I'll put a link to it at the end of the presentation. So I suggest you watch that if you want to have more information about that. In terms of the right-hand side here, so Unity and WebXR both have support for OpenXR in some manner, but Unity hasn't yet implemented hand tracking support. We think it's coming soon, so hopefully we won't have to wait too long. And if you're really desperate to use it, there is actually a way. It's a bit of a hack, but we have published a blog post on how to do that if you are really keen. WebXR is the standard for building XR applications in web browsers, and the browsers use OpenXR as the default runtime, or the default API for runtimes underneath that. There is a proposal from the Immersive Web Working Group for hand tracking data via WebXR, and it's been supported in some mobile browsers, but as far as I know, there aren't any desktop browsers that have actually implemented that yet. But again, it should be coming pretty soon. So that's OpenXR. Whether or not you're using it, so even if you're using a proprietary API, the chances are you're going to be using some kind of game engine if you're developing for AR. So let's talk about game engine tooling. So far, I've kind of just been talking about the plumbing, about how you get the data, the hand tracking data, up to the application layer in a nice kind of cross-platform way. But once you've got the data and you're able to use it, you need to do it something actually useful with it. So I tend to break this down into kind of two areas, which are visualization and interaction. So when I say visualization, I mean using the hand tracking data to render something to the headset. So in AR, this is really important for occlusion. So occlusion is when you have something pass in front of something else and therefore can't see the thing that's behind it. So for instance, if I'm in AR and I'm rendering a virtual object here, and I pass my hand in front of it between my eyes and the object, I would expect not to be able to see the object anymore because my hand is in the way. If that doesn't happen, if the application doesn't know about my hand or doesn't occlude the object properly, then what I would do is see the object even though my hand's in the way. This is really bad because it breaks the sense of immersion, the sense of that the object is actually there in the physical world, and it would almost kind of look as if the object has sort of now appeared in front of my hand. So the good news is that occlusion is pretty easy to do. If you're using a North Star, you just have to render a flat black hand that does not interact with light or shadows in any way. And what this will do is render as essentially see-through on the headset because the screens aren't contributing any light to that area of the screen. And obviously your game engine will just render a black thing rather than the object that's behind it. So it's really easy to do, and it's really important. You can also do visualization with hands. So VFX can be quite important. You'll often see applications render sort of outlines of the hands to give the user a kind of clearer idea of where the application thinks their hands are, and that can be quite good for feedback. Visualization is also really useful for debugging. You'll often see applications with capsule hands, like here. And again, this is just so that the developer can get an idea of whether or not the hand is being tracked and what the tracking pose is. And also social is really big. So if you're doing some kind of multi-user application, if you have other people in the same sort of augmented reality space, it's really useful just to be able to do things like point at things or wave at people. And again, you can do all that just by visualizing the hands. So for interaction, this is more about providing input. So this is when you're actually going to be using your hands to interact with some kind of virtual object in some way. And I've kind of broken it down here into 3 things, but really there's a lot of overlap here, and you could write a much, much longer list. But by UI, I kind of mean things like buttons and sliders and fairly kind of typical UI elements. They're really useful if you want to have kind of a lot of controls, particularly ones that are quite dense. Physics is more about being able to interact with objects in a kind of more physically realistic way. So being able to pick things up or throw them or just sort of flick them or whatever. It's really cool when you can do this in AR. It really kind of helps the believability. And finally, gestures are usually things like pinches and grasps, quite common gestures that are being used. I'll talk about some kind of guidelines of how to do that in a moment. I mentioned that there's some overlap, so you might use certain gestures, for instance, interact with certain UIs. And again, you might have like UIs that consist of physics buttons that you actually have to physically press and they're attached to a screen, for instance. So next, I'm going to talk about some guidelines for design. So a really good thing to do is make interactions physical. This helps people leverage their kind of real world experience and really minimizes the learning curve. If you see something in AR that looks the same and behaves the same way as the object does in real life, people know how to use it already. People have a lifetime of using their hands for interacting with objects, with physics. So it's really great if you can do that. If you have to use, like recognize particular poses or gestures, use them really sparingly. So we can see at the bottom in the middle here, we've got an application where we're sort of painting via pinching. That's okay, because it's the only interaction in this whole application that uses pinching. What we tend to find is that if you use too many kind of specific poses or gestures, people find them hard to learn in the first place and hard to remember when they come back. They're also not very discoverable for users who don't know how to use them already or skip the tutorial or whatever. Also, they can often conflict with other actions. For example, if you have like a pinch gesture that does something specific, but you also have a little object in your scene and you try to pinch it and then it activates the object, so it activates the action, that's probably not what the user intended to do. So they can conflict in that way, and it can be hard to recognize gestures distinctly. So you may find that sometimes a user meant to do a pinch, but they kind of use all the fingers and it gets recognized as a grasp instead. So if pinch and grasp do 2 different things, then that can be a problem. But that's okay as long as you just use them as little as possible. Feedback is also really important. So in AR, when you're using kind of mid-air hand tracking interactions, you don't get any haptic feedback because you're not touching anything in the real world. That can be okay as long as you kind of substitute that with other forms of feedback. So we find that as long as you provide some sort of visual and audio feedback, often users won't miss the haptic feedback that much. And you also got to think about user comfort. One really big thing is to try not to make users lift their elbows. If you have to lift your elbow, you'll find that your shoulder tires out really quickly. So try and keep anything low and think about where the user is going to be using this. If they're going to be leaning their elbow on a desk, for instance, then their hand could be quite high, close to their face even. But if they're standing, their elbows are going to drop to their sides, their hands are going to be further down towards their waist. also tried to limit the number of repetitive actions that users had to do. So Ultraleap publish XR design guidelines, and again, I'll put a link to that at the end. And they can just kind of help you with a lot of stuff that we've kind of already learned over the years of doing this. So you can use the raw hand tracking data to do all this stuff, but it's much easier if you use a toolkit that provides some functionality. So I'm going to start by talking about Unreal and what you can do in that. So actually, I'm just going to apologize. I don't know as much about Unreal as I do about Unity. So sorry if I've missed anything obvious. Hopefully you'll let me know if I do. But as I mentioned earlier, Unreal has support for hand tracking in it already. So what you can do is just go edit, plugins, search for OpenXR, and then enable OpenXR hand tracking. And what this will give you is the hand tracking data, which you can get in LiveLink, and then use that to drive a rigged hand model, which means that you can do visualization really easy, kind of out of the box. If you want to do interaction, then you'll need a toolkit to help with that. So there are kind of two ones here. There's MRTK and Ultraleap's own Unreal tooling. MRTK is sort of split into UX and graphics tools. The UX ones are the ones you want if you're doing hand tracking stuff. The graphics tools don't really contain that much about hands because you kind of do it with Unreal anyway. And the MRTK tooling is mostly based on OpenXR as well. It's particularly good for building complex 3D UIs and for far-field interactions. So these are interactions with objects that are kind of out of arm's reach. Whereas the Ultraleap tooling is good if you want to do sort of custom hand models and sort of hooking them up to the data and some basic interactions. We don't have OpenXR support in our tooling yet, but it is coming very soon. So Unity, this one, you've got a few more options. And as it doesn't yet support OpenXR for hand tracking, you'll need a toolkit to do visualization as well as for interaction. So the first thing I'm going to mention is Esky, which is a toolkit for building AR applications, particularly with North Star. It's developed by Dr. Damo, who gave a talk last week, in fact, as part of this talk series. And yeah, go watch his talk. It's great. It'll show you how to get started with this and yeah, get up and running really quickly. So there's also MRTK for Unity. So MRTK, sorry, I didn't mention earlier, it stands for Mixed Reality Toolkit. It's maintained by Microsoft, and its kind of primary target is HoloLens 2, but it is also cross-platform. It's actually integrated into Esky, so if you kind of get Esky, you get MRTK for free, and that's probably the easiest way to get started with North Star development. And again, MRTK is great for these sort of complex 3D UIs. So you can see in the screenshot here, we've got a bunch of UI elements there. They're sort of curved so that the ones that on the edges are still close to the user, which is really handy. And we've got this other sort of like little tray down here. It's really easy to build all this stuff in MRTK. And again, if you have something out of reach, MRTK has a system where it projects a pointer essentially from a hand, and you can use like a pinch or a grasp gesture to sort of activate whatever the pointer is pointing at. There's also XRTK. So this is actually a fork of MRTK, but it's more community-led. And the idea is that it's less focused on HoloLens 2 as its kind of hero platform. HPTK, so HP stands for Hand Physics. And this is mainly a Quest toolkit. but it also does support Ultraleap hand tracking. The kind of focus of HPTK is that it provides physics where the hand doesn't visually penetrate through objects, which is important in certain use cases. So if you care about that, it's good for stopping hands from clipping through things. And last but not least, there is Ultraleap's own Unity tooling. I'd say it's particularly good again for things like rigging custom hands. It also has a system for letting hands interact with Unity UI. So if you've built your UI in Unity already, then you can just kind of retrofit it so it works with hands as well with our UI input system. And it's also really good for physics. So with Unity, we've built the interaction engine, which is a system for allowing hands to kind of physically interact with virtual objects in a fairly kind of realistic manner that's very easy for users to just understand and use. So you can do things like just pick up objects, you can throw, you can sort of tap things around. It's pretty intuitive for the user when they get started. So yeah, that's really good. And the great thing is you can actually mix and match some of these a little bit. Hopefully this video is going to work. So before I play the video, this is MRTK plus the interaction engine. And what I do is I use MRTK for far field interaction, and then the interaction engine for when the object is within reach. So I'm just going to play this now and apologize in advance for the frame rate. So the green cube, you can see there, I'm just hovering my cursor over it and pinch, pick it up and bring it closer. Now that it's kind of within my reach, I can just, nudge it, pick it up in a moment, there we go. So that's two completely different systems kind of working together. In this case, I just turned off near field interaction from MRTK. So it was, pretty simple, but it works. Okay. So let's talk about the future. I'm going to start by talking about what Ultraleap are working on, and then I'll go into some more kind of general predictions. So we are making Linux support for our new Gemini hand tracking. We are expecting to release a beta of that in the first half of next year. We're also making sure our Unreal tooling has feature parity with Unity. So we'll be bringing the interaction engine to Unreal. We're also making OpenXR support for Unreal, as I mentioned earlier, and we'll be bringing that to Unity once Unity have implemented that hand tracking support. We're bringing a bunch of quality of life improvements to our Unity tooling. So we'll be doing things like releasing a UPM package, supporting Unity 2020 and the XR plugin management system, and like a whole bunch of other things just to make it kind of smoother and easier to develop with our tooling. We're going to be bringing new features and enhancements for both Unity and Unreal, and again, trying to keep that kind of feature parity between them. For OpenXR, we released a beta of our API layer last year, and we're going to be bringing that out of beta very, very soon. We think that's ready and it's stable. And the beta 4 that we released recently is pretty much the exact same thing that we'll be releasing for the V1. We'll also be releasing elbow joint extension for OpenXR. So earlier when I showed the image of the data that you get via OpenXR, I showed 26 joints on the hand, but our hand tracking can also track elbows. So we're going to be adding an extension to OpenXR. That means if you're using Ultraleap tracking, you'll also be able to get elbow data as well, which means that you can bring the forearm into your applications. Okay, and this is some of the stuff that I think is going to happen in the kind of wider ecosystem. So I've talked about OpenXR a lot. I think, it's going to get adopted sort of across the board. And what we'll see over time is that proprietary APIs will start to be deprecated. So that means that hand tracking providers will be providing all their functionality via OpenXR, and also providing any new functionality via OpenXR rather than their own proprietary APIs. We'll also see new features coming in via OpenXR. So this, I mean more things than just joints. So more higher level information, more information that hopefully makes it easier for developers to actually build hand tracking into their application. We're going to see better physics. I think we've now seen a lot of the major players realize that physics is actually really important for hand tracking in AR. And even with the state of the art, even with the Ultraleap interaction engine, there's still a few bits that are a bit janky. So we'll be improving them, and we'll be seeing more physics toolkits getting better and better. We'll start to see a common set of interactions be developed. So think things like pinch zoom on a touch screen, or like two-finger scroll on a trackpad. At the moment, this doesn't really exist for hand tracking. There's no kind of common agreed set for how you do a particular action. But over time, we'll start to see these kind of settle down, and everyone kind of agreeing more. And we'll start to see tooling that supports these use cases better. So I kind of mentioned like pinch and grab earlier. We're starting to see them as like common interactions. So we'll see tooling that supports recognizing those hand poses and the gestures that turn out being the equivalent of the pinch zoom, but for the AR world. And we'll also start to see integration with other inputs. So I kind of mentioned that hand tracking is the most important input, but it's not the only one. Two other big ones are going to be voice and eye tracking. And we'll start to see these input mechanisms be kind of combined and become more powerful than they were separately. So for example, if you imagine that I have a number of virtual windows in front of me, it might be a lot easier for me to point at something and say, select that, than it would be to use voice input to say, on the window number 2, select the item that is second from the right in the 4th row, for instance, or to just use hand tracking, and maybe if the object is quite small, pointing at it and pinching might cause the cursor to move or something. So when we combine these input mechanisms, they become a lot more powerful. I think we'll start to see a lot more of that in the future. So that's it. I've got some links to all the talks I mentioned and some pages I mentioned in the talk here. And I think we can open it up to questions.
Thank you very much, Adam. You can come back with us and if you want to stop your your share. Perfect. Yes, thank you very much for this overview. Was really interesting.
Yeah, it's really cool. Yeah, I really like the. I mean, it was really nice to see the all the explanations about using Unity and Unreal. I think it would be super useful for who's just starting with end tracking and visibility. Trying to discover. I mean, like researcher actually, they also try to discover certain things, new things. I think it's pretty cool. Way also, thank you for pinpointing people also in various videos, and also in and mentioning the different stereo kit and Dr. Jamo Eski. I think it's really nice actually, so people can connect dots between the talks.
All in just ecosystem.
Yeah. Really excited. I mean, we're a big fan of. The talk series it covers a lot of open source projects, so we're really excited that about the Linux support that upcoming as well that you mentioned. Yeah, so yeah, I don't. Yeah, we don't. Actually, our questions. It's more like I know actually you do a lot of. I'm more um, it's a more artistic questions than actually a technical one. I think it's like it's I think it's a lot of our talks are technical, but and since actually they're shared with university and researchers, but we cover would be interesting to see of I don't know, like it's more like it's our also from a usability is not just a software, a pure code, right? So it's also and how you see I don't know how do you how you I we believe actually tools aren't there yet to develop such usability. I mean, there are technologies there, but tools aren't there, like user friendly tools. How do you think actually if a usability designer or a designer that actually wants to get into designing interfaces or usability should do it? Should you go towards it? Using objects itself, like in paper and so on, using certain tools, using Unity. That maybe it's a bit. Cause anyway, if you can share your idea and thoughts about it.
Yeah, so I think you're right that the tooling isn't really quite there yet. So we have like UX people in-house, and they do a lot of drawing on like whiteboards and paper and post-it notes and so on. So you can kind of like they're very good at second 3D by that, but some of them are starting to learn Unity to just a basic level where they can sort of start to manipulate objects and scenes a little bit and lay things out and try out, if you put something there, what might the ergonomics of that look like? But really, at the moment, we do find that we have to kind of pair a developer with them to do that. I think that's like kind of our fault for not really getting the tooling yet to the point where it can be used by designers at this point. And we definitely do have a push to try and get it there. We have user personas, and we're always trying to see like, can we get this to the point where like non-technical person could use it? But yeah, I think we don't have the tooling like we do for web for AR and VR just yet, but it should be coming.
Will we ever have some more common swipe gestures similar to what we have in mobile?
So swipe gestures in particular are kind of a pet peeve of mine. I've tried to implement swipe gestures, I don't know how many times. They're really hard in midair. So to give you an example, say that you have the ability to swipe both left and right, and you see the hand doing this, someone wants to swipe quickly. Do they mean to swipe left or right? Like you're just seeing this. It's really hard to know. So I don't think that kind of swipe gesture is going to happen. I think that these kind of context-free gestures are really quite awkward and difficult to implement, to recognize properly. But if you add context to them, it becomes a lot easier. So for instance, if I have a sort of like virtual turntable in front of me, then when I kind of touch it, then I can like swipe it and spin it around. That's a lot easier. So I think that we will get that kind of thing, but that will often not be implemented as a gesture per se, but more as a kind of physical interaction.
Okay. Yeah. that's a definitely good point of of not being involved. Yeah, it's where you're going left or right. Yes, makes sense. Yeah, I think we don't have any more questions. So we will like to thank you again, Adam, for being here with us, and everyone actually is watching the stream and will watch the video further later. And yeah, so thank you again.
Thank you. And if you're interested in open source in AR technologies, you can meet us here on Tuesdays, as we will have more guests coming. Next week, we'll have Bastian Olej. He will give us an introduction to the Godot game engine and provide a bit of history of its journey in the XR world. He'll also show you how to put together a simple AR game using the North Star headset. And we would like to thank all our partners for their support in this first open source AR talk series. And if you'd like more information on ATPeak and the lineup for the open source AR talk series, visit our website atpeak.io. Hit the subscribe button to not miss any upcoming event, and check the AR talk series playlist to set reminders for our future guests. Thank you. Bye.